Welcome to our new lesson titled the centroid. The centroid is a point where all medians of a triangle meet. Now I'll guide you through the steps necessary to draw the centroid of a given triangle. So the idea is to find all three medians. So as a starting point, let me try to find the midpoint of the segment line BC. To this end, it suffices to draw the circle which is centered at C and is passing through B. And we draw the circle which is centered at B and is passing through C. As you can see, these two circles meet at a point. I'll call such a point A prime. Now to avoid confusion, we can just remove the circles. Now to find the midpoints of AC, we essentially play the same game. Move it to the side. So take your compass and draw the circle center at A and is passing through C. Be this, and then the circle which is centered at C and is passing through A. Take your ruler and find the line passing through the point where the two circles meet. It will intersect AC at a point. Call it B prime, and we'll erase the strokes. All right. Now we need to find the midpoint of AB. Again, we'll play the same game. Take your compass, center it at A, and find the circle center at A, which is passing through. Okay, so now we can find the midpoint of AB. We'll call it C prime. And now we will draw the medians. You can see that indeed all three medians are concurrent and they pass through this point here. Oops. Which we call G, and G is the centroid of the triangle ABC. The following theorem states that the three medians of an arbitrary triangle are concurrent at a point that lies 2/3 of the way along each median from the vertex of the triangle toward the midpoint of the opposite side. So in other words, inside this triangle, if this is the midpoint G, then essentially we can say that AG will be 2/3 of A prime. BG is going to be 2/3 of B prime, and CG will be 2/3 of CC prime. That's a reformulation of the theorem. Now let's try to prove this result. So we really want to show that AG is equal to here 2GX, where let me draw. So this will be that, and then this will be G. So we want to show that AG is twice of GX, right? In order for AG to be 2/3 of AX, it has to be twice of GX. Now, remember that there is a result which says that if U and V are midpoints, so let me recall the following. If U and V are midpoints of side AB and AC respectively in some triangle ABC, then UV must be parallel to BC. So remember this result which we have seen a while ago. Then if we appeal to this result, we look at the, so because X is the midpoint of BC and Y is the midpoint of AC, then looking at the line XY has to be parallel to AB, right? Yes, XY is parallel to AB. Now, let's consider the angle BAG. That'll be this angle, and I will consider the angle YXG. Let's see, I'm sorry. So BAG is here, and YXG is here, and I will call this angle here alpha and alpha prime. So clearly, since alpha and alpha prime are alternate interior, we can say that alpha is equal to alpha prime. Okay, now let's consider the angle ABG. That'll be this angle, and the angle XYG. So this one here, I'll call this one here beta, and I'll call this angle here beta prime. Then similarly, beta and beta prime are alternate interior and thus equal. So, okay, all right, so now as a result, the triangle BAG, let me highlight triangle BAG here. With this triangle here, and the triangle YXG, you can see that these are similar triangles because the three angles of one are equal to the three angles of the other. Okay, so BAG is and triangle YXG are similar triangles. Thus, we now have that AG over GX will be equal to AB over XY, which is equal to 2. Next, using a similar argument, if Z is the midpoint of AB, then if we play the same game, we can see that CZ crosses AX at a point that lies 2/3 of the way from A to X. And this gives us exactly what we want. Suppose that in a triangle ABC, medians BY and CZ have equal length. We are hoping to prove that AB must then be equal to AC. Okay. First, notice that BG is 2/3 of BY, and CG is 2/3 of CZ. Okay, but CZ is equal to BY, so CG is going to be 2/3 of BY, which then tells us that CG must be equal to BG. So in other words, this is equal to this here. All right. So what we've shown thus far BGC, the triangle BGC, is an isosceles triangle. And if I call this angle here alpha and call this angle here alpha prime, they're the same. They're congruent. All right. Now, notice also that if BY is equal to CZ and if BG is equal to CG, then GZ will be equal to GY. Okay, and if I call this angle here beta, and this is a beta prime, clearly they're opposite angle or vertical angle. So since B is equal to B prime by SAS, we can conclude that triangle BGZ is in fact congruent to triangle CGY. As such, angle GBZ must be equal to angle CGY. So the angle GBZ is this angle here, must be equal to the angle GCY. Should be GCY, must be equal to this angle there. So thus the angle CBA is equal to the angle BCA, and we can conclude that the triangle ABC is an isosceles triangle with base BC. Therefore, AB is equal to AC. And this is exactly what we need.